Hello everyone, this is the solution to quiz 3. Now, the quiz was about a snake game implementation. We are basically generating the coordinates of the snake. If we would have a graphical user interface, then we would plot it for each line and then we would see the snake moving. Now let's start with the implementations. The snake spawn was supposed to spawn the head of the snake at 8,8 and everything to the right of the head. So let's start with that. Now I have the template here, basically. Now what I'm going to do is I'm going to basically take the snake.head, which is a node. I'm going to allocate that using malloc with size of node. So there we go. That's the first step because I need to allocate that because it's a pointer and it's pointing null. Now, once I've done that, we are going to basically look at the X position. Since this is the head, the position is already given. It's going to be 8,8. So that's basically it now. Once we have done that, it is actually quite easy and straightforward. I'm going to just say head dot next, and I'm going to allocate another node here. And I'm going to use basically the X coordinate here and assign it to the coordinate of the previous node, which is head.next plus 1. I'm not going to change the Y position here. So let's do it like this. Next Y position is going to be the same Y position here. So if I use a while loop, or for loop, I could just repeat this all day long, basically, because it's quite straightforward here. So why is it complaining here? Snake head. Not complaining here, but it is complaining here. I'm not quite sure why that is. Interesting. Well, let's go ahead and put in another next here. There we go. Of course, here we will need next. Next. So there we go. Maybe that's too much. Yeah, that's basically it. I'm not changing the Y positions here. I'm updating basically the X positions. I'm increasing them. And another important thing is to indicate that the next dot next, which is going to be the last node, dot next should be null. So this is basically determination of our snake. This is going to be the tail of our snake. When we don't have null, it will be difficult to use a loop in the other functions here in order to find the point where it basically stops. So, yeah. Let's actually compile it, and I'm curious if it's not going to compile. And yeah, okay, I get it now. We have an issue like that. Let's solve that. There we go. Now when we compile, it compiles. Nice. So basically we're spawning. Now the next function is basically grow, but before that I'm going to try to implement basically the dump function here. So yeah, now the dump function, we can basically assume that there are already 3 nodes there, but I want to be a little bit more fancy, so I'm going to assume that the snake head can be empty, but you don't really have to do that. If it is empty, I'm just going to display printf the snake is empty, and a new line, and there we go. Else if let's see, else if the else statement here is snake head.next, this would correspond to just the head alone. If the next one is null, then I can just basically printf, and this is not necessary, I repeat, and then percentage 2d, comma, percentage 2d, that was given, and then we have a new line. This is going to be the snake.head.x x, and then snake.head y. So these are the coordinates here. Else. Now let me first explain before I move on. You can basically see that we have a point here, whereas here we have basically an arrow here. And the reason for that is that the snake object itself is an object, which is not a pointer, and if this is a struct, you can just use the dot operator here. Whereas the head here is actually a pointer, as you can see here, it's a node pointer. Therefore, when you access the field of a pointer of a struct, then you should use basically this arrow here. So that's quite important to note, because we are dealing with pointers. After accessing the snake.head, we should use basically arrows. Now, I need to start with node pointer temp, and I'm going to start with the snake head here. While, now I'm going to use while because there's no size in linked list. We're just determining the termination here based on this null here. If we reach null, then we're at the end of the linked list here. So if temp is not null, then we're going to basically print this stuff here, but not with a new line, but with space. And instead of snakehead, we are going to use temp, because that's the node that we're interested in at the moment. So then we iterate through a linked list by iterating like temp equals temp dot next. So we're going to the next temp node basically. Once we're done with that, we should basically maybe have a new line here. There we go. So let's first compile it, and then maybe run main here, and there we go. Of course, we're dumping the same position, but you can see we start with 8,8. The X position is increased by 1. The X position is again increased by 1, and that's basically it. Of course, our grow function does not work, and our move function does not work. Therefore, it doesn't resemble the same output as it was given in the PDF here. But we have the first 3 columns and the first line. So the first row, the 3 columns are basically correct at this point. So the grow function is also easy, actually. The quiz here is basically consisting of the snake spawn, snake grow, and snake dump functions, which are quite easy. The trickiest part will be the snake move here. So the grow strategy here was pretty straightforward. We need basically a node pointer temp, which is going to be the snake head. There we go. Then I'm also going to have another node pointer temp rev. So the previous one, the previous node, I'm going to just define it null. And while I'm again cycling through each node in the linked list. So while temp is not equal to null. What I'm going to do is I'm going to assign temp previous one to temp, and then temp equals temp next. So here the aim is the following. When I reach null, I'm basically holding the previous node in temp prev, and that's going to be the tail. So this part here, these lines of code are quite basic when you're using the struct and linked list structure here. And what I'm going to do is basically I'm going to use temp prev here in order to assign stuff from the tail. So we have temp prev dot next, which is basically the next node after the tail, because temp prev is tail. So you might also go ahead and call it tail, then it is tail.next. We're going to allocate it like here. So we're basically allocating it with a new node here. And then temp.next.x is going to be basically temp prev, which is the tail, dot x. So I'm taking the x coordinate of the last one here, and I have allocated a new node. So this is going to be the new tail here, but the position of the new node, so this is basically the new node part here, dot x is going to be the same position as the temp prev x. And I'm also going to copy the y position from that. And again, it is important to go to the next one and assign it to null. Because all our while loops, all the cycling through this whole linked list is relying on the fact that the last element will be null. If that's not the case, if you don't assign it, it might not be null. It might be null, but it also might not be the case. So be actually safe in that case. So I'm just doing that here. So let us compile and run. There we go. Now we can see that we have 8,8, 9,8, and 10,8. And then we have called grow 3 times. So it grew 3 times. Now we have basically 6 nodes here. But we still don't move, and we are just basically dumping that for each movement that is supposed to happen but doesn't happen. So let's move on to move. Now we have these directions here, which is quite nice. And I would assume that you might have issues with the snake move here. This part is quite tricky, but if you know it, if you know the solution, or if you think about it a little bit, you might come up with a solution that looks like the following. So what I'm going to do, instead of moving or copying the whole position of the previous nodes or the next nodes, or basically the previous nodes to the next nodes. So let me open this one up here. So basically what we have to do is we have to update the head here. But then again, this whole data should be copied. Come on. So this data should be basically shifted to the right. And this one here loses its meaning because of the fact that the snake moves in this manner. We are updating the head here, but we just copy the position of the head, the one next to it, the one next to it. Basically, we're shifting it by 1 to the right. Instead of viewing this as the snake, what I'm going to do, instead of choosing this whole row as a snake, what I'm going to do is I'm just going to place the new position in front of this snake here on the first line. So I'm going to place in 8,7 to the front of the linked list. Then my snake kind of grows at this point, but then the head is at the position 8,7. Then everything else is basically where it should be. But then, since I have added 1 to it, I'm going to remove the tail. When I do that, you will see it is quite easy to code this and use the structure to our advantage. Let me repeat it. I'm going to place in a new node as the head, and everything else will be pointed from the new head. So head.next will be 8,8. That next is already 9,8, and so on and so forth. But I have added a new node on top of the linked list, or at the beginning at the linked list. So I need to remove the tail because it moved to left. So I need to get rid of the tail. Therefore, I'm going to create a node pointer new. Let's go to call it new node here. And I'm going to malloc that with size of node. There we go. And let's check the directions. So if the direction is up, basically what I'm going to do is the new node dot x is going to be snake dot head dot x. So if we're moving up, we're not moving in the x direction, but if we are moving up, the y coordinate will change, and I'm basically going to subtract 1 here. That's basically it. I'm taking the coordinate of the head. The head is going to be replaced by the new node, but before I do that, I copy the position, and since I'm moving, the position will be updated, and this is the way I'm going to update it. Else, if the direction is basically down, it's going to be +1. There we go. And then we will have the right here. So if it's to the right, I'm going to add basically 1 to x, and y will not change. If the direction is going to be left, let's have left, then I'm going to subtract 1. So now we have a new node that has the correct position, but it's not the head. So it is easy to basically replace the head. So the new node.next will be basically head here, snake.head basically. And the snake.head will be the new node here. So we're basically updating the snake head now. Hope that this makes sense. If it is difficult to understand, you can use a pen and paper and just use circles for nodes and then maybe put a cross on the head. And when we're adding a new one, the next one, so new node.next, should point to the snake head. And then we're changing the pointer snake head to the new node. So that is the new head of the snake now. After that, we need a node pointer temp here, which is going to be snake head. And then a while loop. You can use maybe temp and temp ref, or since I'm going to delete it, I'm going to show you another version where I can just use one variable here. So temp not next dot next should not be null. If that's the case, I'm going to iterate through temp equals temp dot next. So what I'm trying to do is I'm trying to reach a level where we have basically nodes here, and this one is null here. So I want to have temp dot next null. So this one is temp basically. And what I'm going to do is I'm just going to say, okay, temp.next should be null. So I'm going to replace that with null. Now I have removed basically the tail. So before we do that, we can actually be memory efficient in this case and say temp.next, which was supposed to be the tail. That's basically going to be freed, and the temp.next is going to be null. So let me remove that. So let me recap. I created a new node. I check the directions here, up, down, right, left. I take the snake's head position here and update it accordingly. Once I've done that, I'm just basically assigning the new node next to snake head. So I'm pointing to the snake head, but the snake head is updated with a new node. After that, I'm just cycling through the whole snake. I reach the end, or the one before the tail, and I say that the tail.next should be null. Before I do that, I just free the memory of tail.next, basically. Or the previous one dot next is going to be the tail now. So let's compile and let's run main. And you can see we have basically reached the top left corner with the head. 1, 0, 2, 0, 3, 0, 4, 0, and 5, 0 are the coordinates here. It would of course be nice to have some visualization. I thought about it, but then I just didn't want to do it because it will mess up the whole process here. We are sticking with basic C, so we will stick with basic C. We might have coded the terminal here to have some screenshots maybe, but again, that would overcomplicate stuff. This is still complicated enough for you, I guess, so therefore I didn't want to bother you with the visual details. But if you can code it with a visual library in C or in C++, you can just use this algorithm or linked list with the graphical user interface to maybe develop a snake game. Of course, there are many aspects that we could still have here, but yeah, this is the bare minimum that I could come up with for you to solve in a quiz. So the spawn method, it looks like this. This was basically just you need the basic linked list knowledge here, and you're just placing the head to a certain point, and then you increase the X positions and you just add some nodes to it. Grow is basically the same as spawn, but it is using a while loop to reach the tail, and then it appends a new node to the tail. Dump, you don't really have to have this part here. You can start with this one here. So that snake.head and then the same looping here, and you printf. So up to this point, it's quite easy. Here you have to be a little bit cautious because you need to pick up on the fact that we're basically using the mids of the tail, but we're replacing, or we're placing a new head and removing the tail, placing a new head, removing the tail to sort of emulate the movement here. This could be done with various different solutions here, but I wanted you to force to use basically the linked lists so you can learn the linked list. Hope that this was fun to develop, and hope that the solution helps you out.